Good afternoon and welcome to this new Ariplastics community webinar. Today we will talk about one of our latest products, OASIS SecondSky, developed with our partner SecondSky, and we will have the expert help of Nico Asperger, who will tell us all the details about how this new material can help you to improve your crop productivity in hot climates. Before the start, I would like to tell you about our company. The Armando Alvarez Group is a 100% privately owned company and represents one of the largest family businesses in Spain, with Cantabrian origins and international presence. Through the 17 companies that make up our group, we cover the needs of very diverse but complementary sectors, such as the packaging, agriculture, geosynthetics, forestry, wood, logistics, and renewable energies industries. We have opted for a circular economy model that guarantees sustainable growth over time, promoting the optimization of resources, reducing the use of raw materials, and reducing waste through recycling to give plastics a new life. Through this model of circular economy and more sustainable plastic solution, our clients can respond to the demands of their consumers. I invite you to visit our website, armandoalvarez.com, to learn more about the agricultural plastic solution available for your sector, and also our website, gocircularplastic.com, where you can see more details about our sustainability plan and our eco solution or sustainable plastics, including cover films, horticultural and baler twine, and mulch plastics for your crops. I will also give you a brief introduction of SecondSky, our partner for the manufacturing and distribution of this innovative cover solution. I say brief because Nico will comment in more detail about the company in his presentation. SecondSky by Iris is a breakthrough near-infrared radiation blocking nanocomposite. Nico will explain this in detail during his presentation. Designed to combat heat stress in farming while allowing light in. Developed in Saudi Arabia and tested in some of the world's most extreme climates, SecondSky seamlessly integrates advanced technology into traditional agriculture practice without requiring growers to change how they operate. By embedding the iris additive during manufacturing, SecondSky offers high transparency while blocking peak heat, allowing growers to protect crops, extend growing seasons, and boost yields without sacrificing natural light. On the other hand, I would also like to tell you a little about Ariplastics community, the platform responsible for the organization of this webinar. Ariplastics community is the online platform of Armando Alvarez Group, especially dedicated to the agricultural sector. In this online community, we focus on providing valuable content for our readers. We conduct webinars where we address different topics related to agriculture. We have a podcast also called Ariplastics Community that I invite you to search on Spotify to subscribe, where we also interview specialists in protected crops, animal nutrition, and products related to silage or protagonists in general of the agricultural world. We also have a YouTube channel with videos of interest to the sectors, including testimonials from farmers of different types of crops, and an extensive archive of publication on the web with news, trends, ebooks that you can download on various topics, and valuable information related to agriculture. If you want to keep up to date with everything we do and upcoming events, I invite you to subscribe to our e-newsletter through the website at theplasticscommunity.com. Finally, I take this opportunity to introduce today's speaker, Nico Asperger. Dr. Nico Asperger is the head of product and growth for Iris and its flagship product, SecondSky. Holding a PhD in environmental engineering and microbiology from KAUST, Nico has led groundbreaking research in water treatment and sustainable water reuse, publishing in high-impact journals. With extensive experience in product development, strategic partnership, and market expansion across the Americas and Europe, Nico plays a pivotal role in driving innovation and delivering impactful solutions that empower growers worldwide. It only remains for me to give you a few reminders. The Q&A session will be at the end of the presentation, and from now on, I encourage you to write your doubts on this topic to gather your question. As probably not all of you will be familiar with the platform, just tell you to click on the Q&A button. You will see this button in the bottom menu of your screen. In some cases, and also depending on the configuration you have of the platform, the buttons are displayed at the top. I also wanted to remind you that we have a chat function that you can use to share ideas. Tell us where you are connecting from, for example, which we will love to know. Or would you would like more general information about the topic or presentation? For a specific question related to a webinar topic that you would like Nico to answer directly, we will ask you to please use the Q&A module. Thank you for your participation, and I hope you enjoyed the presentation. Adelante, Nico. Todo tuyo.
Gracias, Carlos. Thank you. And thanks for the summary of the technology. More or less, I think my job is done. That was great. Thanks, Carlos, and thanks Armando Alvarez for the opportunity to talk about what we've been up to in the last few years, starting at a university in Saudi Arabia, as you mentioned. So just to quickly go through a little bit of the agenda. So this series of webinars that we're going to be doing this week, and then there's a follow-on. Make sure that those that are here, come back for the one next week, because that's really the fun stuff. I'll be kind of setting the stage, talking a little bit of why Iris was formed, a little history of where we started, and then talk about the product itself, right? And how we're trying to help change the lives of growers around the world one by one. But the real heavy data discussion on results in the field and so on and so forth will actually be next week. So as I mentioned, we'll go through this agenda, and so let's get right to it. So the introduction. This slide really shouldn't be a surprise to those attending this call, because I'm not sure if climate change affects any market quite as directly as it does agriculture. And that's not even historical trends, right? Day by day, right? Waiting for rain, or if it's too hot or too cold. All of these things affect agriculture quite severely and quite directly. As we know, we have a growing population, right? So the pressure of feeding a growing population increases, especially when we have diminishing resources like water and energy, to be able to feed those people. And so there was this real idea of striving for efficiency in agriculture, which, as we know, consumes a lot of these natural resources. And so every year it seems like we're breaking average heat records. And so what three brilliant scientists got together and tried to solve for was specifically that. Food being obviously a critical, maybe the most critical market out there, they really strove to drive this efficiency to this market where a lot of resources are being taken. And so here, I think we'll take a little bit of time to kind of explain the dream team. These are the three that started the company in a university in Saudi Arabia called KAUST. Quite a unique university, I may add. So there, for those who might not know, it's a graduate only school. So there is no undergraduate degrees. It is people with a bachelor degree already, all coming together to do engineering and medical based research, all focus on driving actual products to market. So it's less fundamental than maybe some research. This is all geared towards bringing new technologies to market. And so a little bit of background, I'll actually start from right to left. So on the right, you'll see Professor Mark Tester. He is a behemoth in the plant science industry. He's got over 60,000 citations, publishes in Nature in what seems to be every other year or every year. And he's been named in the top 1% of global scientists worldwide over the last 5 years. So his dedication has been in plant physiology, plant genetics, and shining a light on plant resilience in very adverse conditions. So high heat, high salinity, things like this. And we'll touch a little bit on his contributions. But with him, we're developing an entire different branch of the company, which is focused on resilient genetics. Then, if we move towards the middle, we have Professor Daria Baran. Professor Mark and Daria are both still acting professors at KAUST, the university in Saudi Arabia where we started. And she is absolutely brilliant. As you can see from the bold text, she was named in the top 12 most talented scientists in chemistry, has received a number of awards, and partially because of her development of the second sky additive that we'll talk today. And then Dr. Ryan Leifers was also studying at the University KAUST, leading research in agricultural engineering. And each one of these three scientists brought a different innovation on how they wanted to reduce the inputs in agriculture. So Mark Tester, as I mentioned, is resilient plant genetics. So the angle there was not needing as high quality water, being able to use groundwater, brackish water for your crops. Daria Baran is the lead scientist behind Second Sky Additive, which reduces your inputs in agriculture. And Dr. Ryan Leifers, who also was our founding CEO and drove us to the place where we are today, he had a cooling system which reduced the amount of water needed to cool a greenhouse. And so in particularly hot and dry climates, right? So greenhouses will use a wet wall system, which is a pattern fan system or a pared húmeda in Spanish, and actually cooling the greenhouse in climates like Saudi Arabia takes up 90% of the water use required for growing a crop, right? And only 10% more or less is used for the crop. And so each one came with their angle on how to reduce inputs and maximize outputs, therefore gaining efficiency in agriculture. What we will cover today, because it would take more than just 30 or 40 minutes to talk about each one of these, will be Daria's invention of Second Sky. So you have three brilliant minds that come together and make their own products. Great idea, great impact. Okay, job's done. We can just clean up and go home. Not not exactly. So we actually had to take these technologies to market ourselves, and we did so by forming our own fresh produce brand in Saudi Arabia, one of the most extreme climates to grow in, and prove the technologies could work in bringing fresh produce to market. And so that's how we actually started under the name Red Sea Farms, taking advantage of the technologies that were developed in the lab, joining together, forming Red Sea Farms. And we actually scaled that business to be able to sell fresh produce. It was fresh tomatoes, snack peppers, and snack cucumbers into over 300 supermarkets across the country. In 2023, a competitor, Pure Harvest, which some of you might know, acquired the existing greenhouse. So that greenhouse that we were operating is actually still producing fresh produce, just under a different brand, and again utilizing the technologies that we developed. So we recognize that we were not farmers, but okay at developing new technologies. And so in 2023, we made the conscious decision to focus on bringing product development with our partners like Armando Alvarez, and leave the growing to companies that were really experienced in that already. And so today, we are focused on bringing technologies to market. And the main three that we are now commercializing are the genetics arm, which I briefly mentioned, thanks to the work done by Professor Mark Tester and his lab. And then Second Sky, the nanocomposite, the nanomaterial that we're integrating into different forms of plastic, which is what we will cover today. And then there's an auxiliary piece, which is Second Sky Data. We actually developed hardware and built an entire software platform and user interface to be able to show farmers what the technology was doing in their growing systems. And so without further ado, now we can move on to the Second Sky product. I hope that gave you guys a little bit of context of how we evolved over time from being on the lab bench, thinking about how can we actually impact agriculture, to bringing fresh produce in an extreme climate, showing things like season extension, and then finally focusing on a product that will have bigger impact by partnering with people like Armando Alvarez. So this will be the most technical slide of the presentation. So just do bear with me because it is important to understand a little bit of the light spectrum before we get into the performance and so on and so forth. So here we're talking about agriculture, right? So this is all around plant growth. So this is a wide spectrum, but let's talk about what the plants actually use, what the plants actually see. So plants photosynthesize to grow, and they absorb at certain wavelengths of the light spectrum. All of that falls within what we call the PAR, or photosynthetic active radiation. That is between 400 and 700, some argue up to 750 nanometers, but really we're within that range. That is potential production. That is potential growth for the plant, so potential production in terms of fruit yield and so on and so forth. So this is precious, right? We're trying to protect this. And before the visible, so looking at the ultraviolet radiation, it's just because the plants don't see it doesn't mean that it's not important in this case. So pollinators use this to orient themselves, which more efficient pollination leads to more efficient production, of course. And so ultraviolet is also extremely important. And also in things like floriculture, it gives colors to red roses, some color varieties of lettuce as well. So ultraviolet also very important in agriculture. Beyond 750 nanometers, there's around 50% of the sun's energy that we feel on Earth is actually in the near infrared. And this is critical in some regions which experience heavy cold during their growing cycles. In places like Canada, the Netherlands, really the places where greenhouse growing originated, they utilize this to maintain heat during their growing cycles. But what we're seeing and what we're learning is really in the 90% of agriculture is done in high radiation areas. And so not only do they not need the near infrared to produce heat, we're actually constantly looking for strategies to get rid of heat, ventilation, extra shading, ways to really control temperature while maintaining good light levels. And really that's what SecondSky is trying to bring to growers, is maintain your light levels while reducing your heat, right? So our whole motto is more light and less heat. And so how do we really do that? How does the product actually look in terms of these radiations? I'll try and annotate a little bit here, so please bear with me. But if we're looking at a transmission curve, okay, let's try that again. Give me 1 second. We'll try it. Yeah. If we're looking at a transmission graph, a typical film will have a transmission of whether it's a 75% transmission or a 90% transmission, right? So going from 0 to 100 and nanometers across the x-axis here. A high transmission film will have a direct line, straight line across. A 75% transmission will have slightly lower transmission. And then when we add shade, we start going a little bit further down and further down the transmission values, which is great. That helps us combat against temperature. Where it doesn't help us is with maintaining those high light levels. And so obviously this is freehand, this is not exact. But if we look at a transmission for SecondSky, we'll have a high transmission in the UV, high transmission in the visible, and then we drop off in the near infrared. And this photoselectivity, where we're able to block the radiation that is responsible for heat while maintaining the radiation that's responsible for production, helps get that productive environment for the grower, the types of conditions that their crop is looking for longer extended periods in the cycle. There we go. And so, as many of you are probably already doing about thinking about how to utilize this, how to growers, what kind of benefits it brings, you can imagine we're talking about a heat blocking solution. And so that very efficient blocking of the near infrared produces less heat, which as a consequence is generally giving less inputs. So for the same amount of yield, growers are seeing a reduced amount of irrigation, a reduced amount of labor, really a lot of inputs that go into food production. And then by protecting the PAR while reducing heat, this allows growers to use less shading overall throughout a cycle. And so when we look at it from a full cycle basis, we can actually get to the point where we have more light with less heat, which is a bit of a paradigm shift in agriculture. And that leads to more efficiency and therefore higher profitability for the grower, which is what we're all looking for. In terms of manufacturing, because we do get a lot of questions about how the additive is applied, how it's made, really the behind the curtains. So polyfilm, or yeah, primarily polyfilm, is made in separate layers. You can have a 3-layer, you can have a 5-layer, you can have a 7-layer. We've even seen people flirting with 9-layer film. And so these different layers allow us, or allow the manufacturers rather, to integrate different additives at each layer so that they don't interact with one another and counterbalance each other. And so the SecondSky additive is actually embedded within the central layers of the plastic. It's not exposed to the external factors, wind, sand, etc. And so it doesn't degrade over time. The film does not migrate between the different layers of the polyfilm, and it does not degrade based on UV. There is a slight loss in efficiency, but we also use this in harder plastics like polycarbonate and acrylic that have 10, 15, 20-year lifespans. And we know film is generally switched every 2 to 5 years, really. And so the efficiency of the nanomaterial remains. It's not degraded by UV, and it's fully compatible with other additives. So because you might have a SecondSky film doesn't mean that you can't tune diffusion or also have it with a thermic additive for that winter protection. So it's actually compatible with any other additive that you might use in your film. It just gives a bit of spectral tuning to be able to have that efficiency that we spoke about the most light for the least amount of heat. So really thanks to the partnership that we have with Armando Alvarez over the last few years, we've seen traction in several different markets and have even learned about our own product and how to position it in the different markets. And so you'll see over the last few years, we're in over 16 or 17 different countries. We've tried it over 10 different crop types in different growing systems. Well, here we go. Here's some visual representation of those different locations and different growing systems. So anything from a nursery to tunnels or these Canarian greenhouses or higher tech greenhouses. We've really adapted the product to these different growing systems, because part of the challenge in a very commoditized market was decommoditizing plastic, because the nursery in the USA and California might need a different solution than a strawberry grower in Mexico. So really working together with Armando Alvarez, we've been able to give tailored solutions to these different crops and different markets. While going into these different markets, we thought it would be very beneficial to kind of bust some myths, some of the things that the ideas that people might get, the things that we hear on the ground from growers themselves. So the first one is the SecondSky additive sprayed onto the cover? And as we just explained, it is not. It's actually mixed in, it's melted in with the prime material and then embedded in the central layers of the plastic, right? So this ensuring the durability, the stability of the additive. Another one is, does it affect thermic properties of the film? And it does not. So I'm actually going to go back and explain the far infrared. This radiation actually doesn't come from the sun at all. When the greenhouse absorbs the heat coming off from the sun, the heat that we feel throughout the day, that emission of radiation is far infrared. And so many people on this call might use thermic films, and they work by reflecting the radiative heat back into the greenhouse. So what the energy that comes in, you try and maintain it for long periods of time. And we've used this together with SecondSky. Why? Because in markets I'll use Mexico as an example, they use thermic plastics to maintain heat in the winter, but in that same winter during the day, they will be at 22 degrees outside. And so they have to ventilate again, losing that energy that they paid to generate inside the greenhouse, those that have heating systems. And so in a lot of these warmer climates closer to the equator, they'll need some heat to mitigate for those cold mornings. But really, the cold occurs when there's no sun, right? And so our additive will not have an effect of the minimum. So what we see, generally speaking, is we start at the same temperature as a regular film during the night, and we cut off the peaks of temperature in the bright parts of the day. And so at night, the second sky additive has no effect. It's a different portion of the spectrum. So it works great actually together with the thermic additive. In Mexico, we do have examples of being able to shave the peak with second sky and then together being able to increase the minimums thanks to the thermic additive. The myth about the additive not lasting the lifespan of the film, I think I touched on that a bit when I spoke about polycarbonate and so on. So there's a slight loss in efficiency, but the interesting piece about the loss in efficiency is that actually the additive, when it loses its efficiency, becomes more transparent. So actually we're giving more light back to the grower. And about reducing the temperatures in the greenhouse in the winter, I maybe jumped the gun there and gave a little bit of a preview. This is really about peak heat. We're not a AC unit. We're not reducing temperature. We are selectively reducing radiation, and temperature is a consequence. And so when there's very little radiation, like in the winter or in the early mornings, second sky has little effect on temperature. When there's lots of sun and lots of radiation, this is when we see the value add of keeping high levels of light while reducing your heat. And it would be great if we were able to give presentations like this and every grower wanted to buy their entire farm worth of plastic, but that's not the case, especially in agriculture. We really need to show the value of the product in the different geographies, the different crop types, the different growing systems. And so the Second Sky data platform that we've developed helps us do just that. And so with strategic growers that are willing to share data and information about their growing system, we actually provide a sensing tool, which is 100% remote. As you can see, it's attached to a solar panel, and so we don't need access to electricity. We use a long wave SIM so that we can have it in remote areas and be able to acquire that data. And we can look at that data irrespective of where we are, and we see it live. And so it reports our EnviroSense sensor, which is what we're showing here, reports temperature, humidity, air pressure, but crucially also has a light meter on the top of it. You'll see the little button sensor at the top. And therefore, we can calculate things like DLI, the integral of light throughout the day. We can calculate things like vapor pressure deficit, which gives an idea of how efficient the crop can use its resources, and really help the farmer not only see the benefit of our product, but actually make mid-cycle decisions on crop management, which has been the feedback has been great from the growers. So that's the environmental sensor. The soil sensor, similar measurements, moisture, temperature, pH, and we can actually get down to specific nutrients, although sometimes in a soil matrix, those can be iffy or they need a little bit of calibration, right? You have a lot of noise in the soil. And so together with this, we're able to show the value of our product to the grower in real time and not always have to wait about the yield per square meter to determine whether the technology is, number one, working or fit for this particular client. And so we're able to make decisions after one cycle, for example, instead of maybe 3 cycles, pairing the environmental data with the growth metrics that are shared from the grower. This is what the platform looks like. And so each grower that gets the sensors gets an account as well, obviously has access to all of their own data and can really customize their own dashboard, right? So if they make decisions based on par light and temperature, that can be nice and big on your platform, and it can show you historical data, it can show you live data. We can generate graphs from here quite easily to show differences between a control greenhouse or a standard film and our differentiated product. And so again, with this is really a show me tool that it's not just our word and it's not a blue paint that we're adding to the film. This is really a differentiated product that should impact your crop management, right? So just like where we see in an outdoor setting to a covered setting, there's an adjustment in management. We're seeing that to get the most out of this new technology, going from a standard film to a differentiated product, there also is a slight adjustment in management. And my colleagues will go in more depth into what that difference is. But just to say that the sensing tools have been crucial in quantifying that value add for our growers. So thank you all very much for listening, and we'll open it up for questions.
Thanks, Nico, for this great presentation. Now, as you say, it's time to answer the question. The first one from Stevie. From all the trials and grower feedback you have seen, what has been the most surprising or unexpected benefit or of using Second Sky in different climates?
Yeah, thanks, Carlos or Stevi, for the question. The most surprising was I would say the increase of the minimums in the winter cycles, right? So we actually have, I don't know if you guys remember the map, we actually have installations in the UK, which was definitely not on our top list of target markets when we thought of this technology. But the compatibility of being able to use a heat blocking additive with a heat saving additive, if you will, was probably the most interesting to me, because there's slight nuance there in that our additive helps retain moisture in the soil and in the substrate. So the combination of extra humidity in your substrate or soil with a thermic additive has actually increased those minimums where 1 or 2 degrees can make a huge difference. So I would say the applicability in these colder times of the year was probably the most surprising.
Okay. Another question, Nico. How do potential growers get in contact to immediately begin utilization of Second Sky?
Thanks for your question, Carlos. So we can be found on really different modes of social media. You
Mhm.
can find us on LinkedIn. We have a iris.com website as well, where it will put you in contact directly with our team, and our team will then point you in the right direction on who your distributor is in your region, or so on and so forth. And so our website, our LinkedIn pages are the easiest way to get in contact with us.
Okay. Nico, Jose Fernandez says, how does Second Sky compare to traditional setting solutions like chalk or netting?
Thanks for the question. It's a great question, right? And so the benefit of Second Sky versus these other shading solutions is really the photo selectivity. Um, the whether you have a 15% shade or a 25% shade, you're removing the same amount of heat as you are light for the plant. And so the value add of the Second Sky is that we can protect the amount of photosynthetic light that you get while reducing your temperatures. And so you're not having to decide whether I want more production or less stress. We can actually deliver a more productive environment while reducing your stress.
Okay. And Nico, how is Second Sky different from other head blocking additives?
Yeah. Again, the answer is actually quite similar. Um, Blocking heat is not something that we invented, right? So this has been around, especially in agriculture, for a long time.
Yeah.
What really separates us in terms of performance is that efficiency, right? So we have some photoselective additives out there and that do compete. For us, for about a 5% reduction in light, we can remove 52% of the near infrared. And so it's really an efficiency play and making sure that we're not cutting off any of your PAR light. So our spectrum shift is beyond the PAR, and the efficiency differentiates us from others in the market.
Thanks, Nico. Patricia de Colombier asked Nico, what is the price difference versus a standard film?
That is a great question and a very important one, commercially speaking, right? And so it really depends. I hate to stay on the fence, but it really depends on what you're using currently. And again, what solution is right for your crop and your market. And so we don't sell the same product in the UK than we would sell in Saudi Arabia, right? So these are two completely different environmental markets, and so they have different solutions. And so it'll vary, to give you a ballpark, between a 15 or 20% increase, and it can be as high as a 60, 70% increase. The percentages might surprise some people, but in reality, when we think about per hectare, it's $2,000 to $5,000 per hectare in terms of additional costs. And when you divide that between the 2 and 5 year lifespan of the plastic, it's really a marginal cost that can produce a quite a big return. And so we really look at things in terms of return of investment, and we see the majority of growers see that return within the first crop cycle.
Okay. Nico, we have another question. Jose Fernandez ask, what is the effect of losing light in the winter?
It's a great question, Jose. So again, the idea of the material is to protect as much light as possible, right? And so to give an example, in Spain, for example, many growers will chalk their plastic during the hot months of the year and then keep them clean during the winter months, right? And so this cleaning and this chalking and cleaning is very common practice, not just in Spain, but across the world. And once you paint and then clean, you've already lost 5 to 10% of your light, right? And so what we're seeing with our additive is actually not a large light sacrifice in the winter, because many of these climates still have to shade during the winter. People think of winter as extreme cold, and that again is really between, in most of these markets close to the equator, between 6 and 8 in the morning, and then in the middle of the day they're using some sort of shade screen again. And so the net loss in light in, I'm not going to say every winter climate, but most winter cycles is actually not significant.
Okay, Nico. We have another interesting question from Patricia Jimenez. Patricia asked that growers often face tough decisions when choosing greenhouse covers. What key factors should they consider when deciding whether Second Sky is the right solution for their farm?
Thanks, Patricia. That's a very interesting question. So, I would say if they're using a shading strategy to reduce temperatures, right? Because different crops need different levels of light, and we do understand that. And so some crops need shading just to grow better. But if growers are using shading strategies or investing in some sort of shading agent, whether that's chalk or shade net, to reduce temperatures only, you would be a perfect candidate for Second Sky. So anyone really using additional shade to their current plastic cover should consider, or at least have the conversation about whether Second Sky is right for them.
Great, Nico. Darren George asked, is there any data on the benefit of Second Sky versus conventional plastics in the Caribbean?
We are on it, Darren. Thank you for your question. We actually have distribution currently in the Dominican Republic. And I will be visiting in about 4 weeks to go look at some of the first growers that have installed the plastic. But looking from the so that'll give you a hard data point for the Caribbean. But looking from just environmental conditions, you guys have high radiation the entire year, right? And there is no real winter cycle in the Caribbean. So the maximums and minimums maintain throughout the year in the Caribbean, because you guys obviously are a series of islands, and so very affected by coastal environments. And so you guys have a very steady environment with very high radiation. And so absolutely, do I think it'll be a it's actually a perfect market for a product like Second Sky, but I don't have a proper case study to give you X amount more efficient or so on and so forth. But hope to be able to give that to you soon, Darren.
Another question, Nico. Here, Marusan ask, does the use of Second Sky eliminate the use of chalking or shadowing, or just reduce the need of it?
Hey, Razan, thank you for your question. In some cases, yes. So it really depends on the region, growing growing system, right? So if you're in a naturally ventilated greenhouse or a evaporatively cooled greenhouse, you have a different situation. So it really depends grower by grower, right? So we see this even when we go into the market to speak to growers. You could have the same variety in the same region, and two growers take a crop differently, right? And so, have we eliminated the necessity to chalk in growers that have previously used this? Yes. Is it automatically eliminating all necessity to chalk? Not exactly. And so we've had both scenarios where I mean, for a fact, you will reduce your shading requirement. That's for sure. How much you reduce it is really up to the crop management.
Thank you, Nico. Ismail Acha ask, does the nanomaterial used in this technology remain stable in the plastic throughout its entire lifespan?
Hi, Ismail. Thank you for the question, and absolutely. We see polyfilms are guaranteed between 2 and 3 years. Some growers will really push it and take it to 5 or 6 years. But because of the physical nature of our additive, it cannot move from where it's embedded, and so it lasts the lifespan of the film, and has very minimal efficiency loss throughout that lifespan. Actually, the outer piece, the actual plastic, will degrade much faster than the additive itself.
Okay, thanks, Nico. Meishaf Shafi gives you the thanks for a presentation and ask if is there any policies data that we can access?
Thank you for your question. If you would like to see some data, we have an unreal amount of data. We do have lots of data points throughout the world. I would say contact us directly. We have no issues sharing data. The idea is getting the data that's most relevant to your region, your crop, your growing system. And so reach out to us on LinkedIn, on our website, and we'll make sure to provide the data that you're looking for.
Nico, we have a new question, in this case from Antonio Perez. Can you explain the relation between Second Sky and the drainage of water?
Yes. Antonio, thank you for your question. So you're talking about growing in pots, right? So growing in substrates or even in troughs with a hydroponic system. These are typically the systems that will measure things like drainage. And we are seeing an increase in drainage, right? So if irrigation is kept exactly the same, when you add a Second Sky plastic compared to a normal plastic, you will see more drainage, which is not necessarily what we want for a grower. The idea is to have similar drainage and actually reduce your inputs. And so this is the type of adjustment in crop management that we try to get to with our growers, and the type of the points that the data platform helps us deliver with the growers. So typically we see a higher efficiency in water use, and that can vary between 10 to 25, 30%.
Thanks, Nico. Um, Last question, Darren, George. Can you speak more on the monitoring technology that accompanies Second Sky? Does Iris offer holistic greenhouse management or control?
Hey Darren, hi again. Thanks for the second question. So we do not do a greenhouse management system ourselves. What we have done in the past is combine our sensing network with existing greenhouse management tools to influence things like irrigation or deploying shade screens or things like this. So it's 100% compatible with greenhouse managing systems, but we are not focused on that currently. We're using the data platform for special projects and as a sales enablement tool for the Second Sky additive, which is the primary focus for the sensors currently.
Thanks, Nico. Last question. Does the additive affect the recycling potential of the film? Do you think?
Thank you for the question, because we're actually proud of the ISO certification that we got, and the answer is it does not. The material is completely inert. It's recyclable, and we actually worked hard last year to get the ISO certification to show. So it does not.
Okay. Perfect. This is all. Thanks again, Nico, for your presentation, your time, and to all of you for your attendance and participation. I just wanted to remind you that when you click on an end webinar session, you will see on your screen a short anonymous survey that I will ask you to please fill out to take into account option for improvement in the future sessions and to know your impression on this topic. The recording of the webinar, the presentation, and contact information, if you want to ask other questions about this topic, will be sent to your emails in the next few days. I invite you again to visit our Ariplastics community website, and we look forward to seeing you in a future webinar. Thank you for your participation, and have a great day. This is all. Thanks, Nico, and see you. Bye-bye.